Welcome. Let us continue our discussion with respect to the mechanism of climate change. In the ninth lecture, we discussed about the orbital concept or orbital insulation concept as far as the given by Milankovitch to understand the mechanism of climate change. In the 10th lecture, let us discuss about other 5 to understand how they also explain the mechanism of climate change. And in this course, we will understand the 5 concepts and 5 different mechanisms. The first one, let us understand the plate tectonics. We all have understood plate tectonics as the movement of the plates, and there was one called Pangea, and it has moved across time. But here in today's lecture, we will try to understand its insulation impact as far as explaining the climate change. The second is the greenhouse gases. Friends, if we take a look at the atmosphere, we have 0.03, now it is 0.0423. So, about 420 plus ppm of carbon dioxide is present in the atmosphere. So, the atmosphere is getting loaded by various greenhouse gases dominantly because of our anthropogenic activity. So, let us understand how this greenhouse gases which warms the atmosphere or which have a warming impact, that is why they are greenhouse gases. So, how they have an warming impact and in turn leading to the global warming and climate change. The third is the runoff. So, we have runoff in terms of freshwater runoff and also the circulation in terms of thermohaline, temperature and salt or salinity. So, this circulation, they also explain this mechanism in terms of climate change, and the aerosols in the atmosphere, how they also contribute as negative forcing in terms of explaining the climate change mechanism. And cumulatively, we will take a stock or we will take a look at the climate of our past century, that is 20th century. So, friends, let us see these kind of diagrams are not new to us. We have been studying and knowing it. So, in terms of the drift, so we say the drift is shifting. So, drift theory, this states that earlier it was one landmass called Pangea, and then during, if we talk about in the Jurassic period, the Pangea broken to 2 plates dominantly called namely they are called the Laurisia plate and the Gondwana plate. So, Laurisia and Gondwana, and then in the Cretaceous period we have started receiving the modern day continents. So, this is what we can see since last 65 million years ago, and this is what is the current day, but it is not fixing, it is not fixed, it is the plates are moving with at a very slow rate, and the impacts or the effects we are realizing in terms of the earthquakes, all of us know it. So, what is the effect on climate? The effect, so if polar drift means ice formation on land. So, if you have lot of space in terms of the landmass at the polar region, that means we are having areas for the ice deposition or ice formation. Antarctica, particularly the Antarctica and South America split, it has given less ocean heat transport, in turn have led to a colder climate. The North-South American joint have given rise to a strong Gulf Stream, and that in turn have led to heat transport. So, and the rise or uplift of the Tibetan plateau has given a cold climate, in turn the formation of Himalaya because of this plate tectonics, the bombardment of this with another plate, our Gondwana with the other plate. So, it has given a broader large scale weather pattern in terms of the monsoon. So, we put it or we understand it in terms of the Asian monsoon, though dominantly it also regulates the Indian pattern. So, we also say it Indian monsoon, but it is the Asian monsoon. So, this region's meteorology or the weather is fixed or is controlled, regulated by the presence of Himalaya in terms of a tall wall. On backside you have the Tibetan plateau. So, these plate tectonics, the movement of the plates, they have given rise to various effects that explains the climate, or you say the climate change. So, these figures have been taken from Hanna's book published in 2011 that explains climate change biology. So, now we will take a look at the greenhouse gases. Friends, all of us know the water vapor, the carbon dioxide, methane, nitrous oxide, and many other. We have many other greenhouse gases including CFCs and others. So, these are the greenhouse gases. All of us know what is the greenhouse effect. So, the earth receives the shorter wavelength radiation from the sun. In turn, it loses heat and goes back to the atmosphere in terms of longer wavelength radiation. So, this longer wavelength outgoing radiation is trapped by the greenhouse gases which are present in the atmosphere. So, in turn, because of the trapping behavior, it gives us a kind of warming impact. We need not have to go in terms of the electrical properties of that or the atomic vibration behavior or property of that, but what we understand is they are trapped, this outgoing longer wavelength radiation are trapped by the greenhouse gases present in the atmosphere. So, let us understand one of the indicative phenomena as far as the carbon or the geological or longer term carbon cycle is concerned. Friends, understanding carbon cycle is an indication of how this carbon rotates and revolves in our cycles, and in terms of a longer term which we understand in terms of geological carbon cycle, that also explain why the ocean or the marine sphere is the second largest reservoir of carbon next to the geological rock or the lithosphere, right. So, have a look at the diagram here, the figure here. You can see in longer duration we have the rock weathering process. So, it can be explained in terms of carbonate rock or in terms of the silicate rock. So, this when the calcium carbonate comes in contact with this carbon dioxide and water, we put it in terms of carbonic acid. So, calcium carbonate, when it comes in contact with carbonic acid, it gives rise to the calcium ion and carbonate ions. Okay. So, bicarbonate ions HCO3 minus. So, this is actually allowing the release of carbon from that of carbonate and the silicate rock through the weathering process. So, carbon dioxide, when it comes in contact with moisture or water, it gives us the acid, that is carbonic acid, which leads to this weathering in terms of rock weathering in terms of carbonate or silicate, right. So, this carbon dioxide reacts with rocks to form calcium ions, or the calcium ions in both cases, and in terms of silicate you get the silicon dioxide. So, that means ion transfer, this bicarbonate ions, they are leaked and leached, okay. LEACH is the leached through the drainage system, and finally it finds it or it rests in sea and oceans, right, in the ocean, in the marine sphere. So, that is what is explained here. So, the carbonate ions and the bicarbonate ions transported by the drainage network, rivers and others, to the sea and oceans. Now, these marine organisms, they come in contact with these ions and they build the calcium carbonate cells, that is their outer cell they build, which and again in that course they release some of the carbon dioxide which comes through this comes into the system through these ions or in ionic formation. And the equation for this is just the reverse of that, carbon the calcium ion plus 2 bicarbonate and the calcium carbonate which is going as the building material of the outer cell, carbon dioxide and water. This carbon is available for release or it is available to the marine sphere or to the ocean. Now, the volcanic activity on this side, let us first finish and talk about this. So, when that particular organism it dies, it decays, the calcium carbonate is decayed is deposited on the sea or the ocean floor and buried. So, that is how it takes it is rested there, and when it is buried in the ocean floor, that means it is again going back to the lithosphere, right. And then the metamorphism at high temperature, calcium carbonate plus silicon oxide, it again gives back to this calcium means the earlier formation of this, and carbon dioxide is again released. So, this metamorphism it leads to carbon dioxide sink at high temperature, and in terms of biological cycle, the carbon dioxide exchange through photosynthesis and respiration, which is we are not discussing here. But this is how the as an indicative of the greenhouse gases, as an indicator of the greenhouse gases, carbon dioxide is cycling in between or among the atmosphere, the terrestrial sphere and the marine. Okay. And some amount of this carbon dioxide is again escape to the atmosphere by or in terms of volcanic eruption or in terms of the soda springs. Coming to the influence, particularly the human influence on the carbon cycle, again this is a very beautiful representation that clearly gives us an indication how vividly our anthropogenic activities are contributing to the recent rise in the temperature. Yeah, if you see here, the x axis is plotted between 1750 to 2010. So, 2010 since last 15 days up to last 15 years. And if we see here, gradually 1850 onwards, this annual anthropogenic CO2 emission have started increasing, and it is shown here that the maximum, the upper one is dominantly contributed by fossil fuel and cement from energy from different energy sources as far as the statistics is concerned. So, lot of this is contributed, CO2 is contributed from or by the fossil fuel burning and even from the cement industries. And the second one, which is shown in terms of the land use, land cover by the yellow kind of yellow-ash figures, that is coming from the land use change from various data and models, and this green one. So, these two are the upper two are representing dominantly the what you say the anthropogenic impact or the human influence. Now, on the now on this side, on the lower side, if we are seeing here in terms of the sink, the lower is the sink by ocean, this one is the measured atmospheric growth rate, and the green one is the residual land sink because of deforestation and alteration in terms of albedo. So, this slide very well indicates or convinces us that human influence on carbon cycle is more prominent, or in general in terms of the greenhouse gas emission is more prominent. Now, move on to the third one, that is the thermohaline circulation. In this beautiful diagram, the picture which has taken from the book given by Hannah, it very well in terms of the color also you can see a variation as far as yellow, the red and little dark red kind of color variation, and yellow and a bright yellow. And look at this, here we are saying we have seen here Indian Ocean, the Pacific Ocean goes here, the upper current in terms of and goes here and comes back, and you have the Southern Ocean here, deep current and cold saline. Heat release to air, Atlantic Ocean here, and heat release to air here. So, what this explains? This clearly explains that the equatorial region are warmer, as all of us know, because it traps lot of earth, or the equator receives more of the solar radiation, and relatively the equatorial water is warm. So, this warm water is where it rotates and driven to the both side to the polar regions where the water is relatively cool. So, in turn it loses the warmth or the loses the heat, and as all of us know, the cold water dissolves more of the carbon dioxide than that of the warm water. So, climate change leads to runoff less ocean salinity. So, weak sinking leads to heat transfer, and we in turn receive a kind of cold or a warm kind of temperature, or followed by cold and means colder or mild winter. So, what this explains? This broadly explains the transfer of heat thermo and a salinity gradient or the salinity variation because of this circulation. So, freshwater runoff, which is mostly coming from the terrestrial landmass through the estuary or through the seas, and the thermohaline circulation, they explain the circulation component and thereby the climate change mechanisms. Now, let us move on to the aerosols, their sources, tropospheric lifetime and climate properties. Aerosols are very tiny or small suspended particles in the air. Large eruptions cools the earth by about 0.1 to 0.3 degrees centigrade for up to 3 years. So, friends, the history says that lot of our deserts have been formed there when we have lot of aerosols and lot of eruptions and all those things. So, aerosol species, sources, lifetime and climate properties have mentioned. These are the different aerosol species. As far as black sulphate, nitrate are concerned, the black carbon and organic aerosol species are concerned, and the sea salt. So, have a look at this, and particularly their lifetime and the climate properties. As far as sulphate is concerned, light scattering, the cloud condensation, nuclear CCN is affected. So, in terms of all they are actually affected in terms of the light scattering and the CCN impact, right. So, let us move on to the fourth one, which is really all of us understand it in terms of the sunspot or the dark spot. As I mentioned, the sunspots are the dark or the black spot. They maintain a cycle or the repeativity in 11 years of epoch. So, 11 year sunspot cycle, it controls the radiation changes. Look at the figure mentioned here, that is plotted from 800 to 2000 years. So, we are now in 2025 and 800 to 2000, let us see it here. this pattern in terms of solar irradiance. Okay, the solar irradiance in y axis is represented between 1364.5 watts per meter square to up to 1367 watts per meter square, and we are seeing a variation as low as 1364 little plus here for 4.6 or 7 up to, you can see it here, 1366 point maybe about 6 or 7, right. 1366.7 is the maximum. And if we see here, we can also see that is during the period of 1645 to 1715, this period 1645 to 1715, this period of 70 years, we have a kind of minimum activities. Okay, so we call it the Maunder minima after the scientist who have discovered it or who have first pointed it. His name is Maunder. So accordingly, it is Maunder minima. So more solar or sunspot activities, more radiation, and few sunspot activities, less radiation. So Maunder minimum explains that during the phase of 1645 to 1715, there are very less sunspot activities. So that is why that time the this is linked to the little ices. So that has led to relatively a smaller or a cooler climate. So more sunspot activities, more radiation, relatively little warmer climate. So this 11-year sunspot cycle, it controls the radiation changes, and in turn the variation of the sunspot number, few and more, leads to less or more solar radiation, linking or in turn reflecting in terms of little ices or more kind of fluctuation, right. So with this 5 plus 1 6, we can now try to corroborate it and get information about our 20th century climate. So global temperature rise, it has gone beyond 1.23, though we have mentioned 0.85 since 1880, but when we take the average of this to calculate the temperature, global temperature rise, we take the average of 1850 to 1900. So with respect to 1850 to 1900, we believe that during that period, if we take it base, because then after the industrial activity have shoot up. So this can be a perfect base period to compare the temperature rise. So since then, perhaps more than 1.23 degree centigrade temperature have risen till last year or till approximately till today. So global warming is happening, the average temperature of the earth is rising, and it has already risen by 1.23 as I just mentioned. Now warming become faster after 1970. If we take a look at the right hand side figure, it is depicted some 1882 2000, and it very well says in terms of the red one talks about both anthropogenic and natural, and the blue one talks about the natural. So if we say, if we delink the natural and delink the anthropogenic and only take the natural, the blue one takes that the natural causes of climate change explains to lesser warming in terms of temperature anomaly. You see the rise in temperature, but when we include the anthropogenic plus natural, the red one with a kind of reddish wash areas from different kind of observational models, they say that yes, because of when the additional impact of anthropogenic is included, the temperature rise, temperature anomaly is well explained. So it is very evident that the anthropogenic induced causes of climate change are the cause of worry and contributing to the temperature rise or the temperature anomaly. The same trend has been also confirmed by different observations as mentioned or as has been seen by the black curve. So, on the transient climate model simulations of the 20th century with natural plus anthropogenic forcings and observation data do agree that the anthropogenic induced changes or induced causes contribute to the recent climate change. Now, let us take a look at the lower left diagram, where we have tried to link the various forcings in terms of the drivers of system change, in terms of the feedback that amplify or dampens the responses, and the R system responses. So, forcing, feedback, natural variability in terms of internal variability and the responses. So, warming become more faster after 1970. All hottest years happened after 1997. Friends, we have started realizing the impact of climate change in terms of extreme weather events. One of them is the hottest years. So, since or after 1997, we have started receiving more and more hottest year, and the frequency is going on increasing. That is one of the impacts of the extreme weather events that we have started realizing in terms of the climate change. And as all of us understand, it cannot be explained by the natural causes alone. The anthropogenic causes is the dominant. So, what are the forcings? The forcing, as we discussed, the solar irradiance, the volcanic aerosols, the anthropogenic aerosols, the carbon dioxide and the greenhouse gas emissions, including ozone and other greenhouse gases, the land use, the alteration of land use, including deforestation, forest fire and many things, and the radiative nitrogen. These are the important or the dominant forcing that explains that contributes or that are listed in as various drivers of system change. Coming to the feedback is alteration in terms of water vapor, the cloud, snow ice albedo, ocean heat uptake and circulations. The soil moisture is impacted, the land cover change, and the carbon cycle and the reactive carbon. These are the different feedbacks we are receiving, and the responses. In turn, let us first also utter these few words in terms of the internal variability, as we have discussed already in the 7th lecture. The ENSO, El Nino Southern Oscillation, the NAO and the PDO, AO and MAO. These actually also goes as the internal variability, and then the responses. As we mentioned, the R system is receiving, or we are receiving, the responses of climate change in terms of variation in temperature. Friends, these days we are having more and more extreme weather events in terms of more of cyclones, more of the floods, more of the hottest year, less of the cold or the cool days, so more of the hot days, and the very less fluctuation in terms of the temperature and all these things, and in terms of precipitation you have lot of sporadic rain, and the rainfall droplets are increasing, and lot of rain in a small time span, and lot of other things we have been seeing. So, as an example, you have lot of fire, and the fire particles, the aerosols, they will interact with the aerosols, and in turn the visibility, the CCN will affect it. So, microclimate, microphysics gives us the explanation. So, all this actually leads to different cumulative things. So, what I mean to say here is the temperature is varying, the precipitation is getting altered, pattern is getting altered, the extreme weather events we are receiving more and more these days. The water resources, the moisture is getting affected in terms of soil moisture and other water resources. The ecosystem resources, the biosphere, the biodiversity, the biota, all of us know about the ocean acidification and in terms of many other marine organisms, in terms of the bleaching and other things have been reported, and it also affects the crop field. Higher temperature also affects the wildfires. We have been seeing lot of cases as far as India, abroad, US, many other places are concerned. So, what I mean to say is, all of us have started receiving the impact of climate change in terms of more and more extreme weather events. So, these two references, particularly the book by Gordon Bonan, Ecological Climatology, and Lee Hanna, the Climate Change Biology, have been referred for, and many of these figures and diagrams have been taken from there and well cited or referred. So, we conclude with this 7 points is plate tectonics safe climate by altering continents, ocean currents, and ice sheet distribution. Greenhouse gases such as carbon dioxide, methane, nitrous oxide, they regulate Earth's temperature. Human activities since industrial revolution increased the carbon dioxide, while land and oceans sequester carbon. Increased freshwater runoff reduces ocean salinity, weakening thermohaline circulation and poleward heat transport. Aerosols from dust, volcanoes, and fires scatter sunlight, affect clouds, and the last one is solar variability at a 11-year sunspot cycle causes minor radiation fluctuation influencing the climate. So, friends, in the 9th and 10th lecture, we elaborately discussed about various mechanisms, dominantly the natural mechanisms and the anthropogenic mechanisms that explains the climate change. Thank you very much.